Hi, my name is Jessica Perez, and today I'll be doing Chapter 4, Problem 56 from the textbook. So the problem states, determine the magnitude of the moments of force F about the x, y, and z axes. Solve the problem A using a Cartesian vector approach and B using a scalar approach. So first we have to identify our givens in step 1. So our given would be at point B, which the force is 4I plus 12J minus 3K pounds. And then we're also given the diagram to the left, which shows that it is going 4 in the positive x-axis direction, 3 in the positive y-axis, and negative 2 in the z-axis. Then step 2 would be to find the magnitude of the moments of the force F about the x, y, and z axes using Cartesian vectors and scalar methods. Step 3 then would be to make an assumption, and I assume that for vector analysis one must assume that when finding each component it is at equilibrium, and for scalar analysis you must find the sum of each component. Then we go to step 4, which is to make a plan, and so step 1 would be do vector analysis by making Cartesian vectors for RAB. Step 2 would be make a 3x3 matrix for each component, then solve for the final value by doing the component multiplied by RAB times the force. Step 3 to do scalar analysis by finding the sum of each component, and finally step 4 would be multiply each length together to find the final value. That then brings us to step 5, which is to make a free body diagram. I then, in the free body diagram, reinstated the lengths again. So 4 in the x direction, 3 in the y direction, and negative 2 in the z direction. And again, I put down force at point B. Then that brings us to step 6, which is the solution process. So we're going to begin with the first half of the problem, which is vector analysis. And we're going to put in RAB into Cartesian vector form. And because it is at equilibrium, you subtract each component by 0. Then that results us with 4I plus 3J minus 2K feet. Then for each component, you're going to have to multiply for instance, x is I. You're going to multiply I by the RAB times the force in a matrix. And because it is in equilibrium, you're going to do 1 for each component, and the rest of the other components that are not present will be 0. So for mx, it will be 1, 0, 0, 4, 3, negative 2, 4, 12, negative 3 within a 3x3 matrix. There we get 1 times 3 times negative 3 minus 12 minus negative 2 minus 0 plus 0 equals 15 pounds times feet. For the y and z, we would repeat the same process. So for the y, you get 4 pounds per feet, and for z, you get 36 pounds per feet. Then we can move on to part B of the problem, which is to use scalar analysis. And again, because it is at equilibrium, you just have to find the sum of the components. And you see that once we do that for the sum of each component, we get the same results as part A. So the sum of x would be 15 pounds per feet, y is 4 pounds per feet, and z is 36 pounds per feet. So either method you choose, you should get the same results. And that is the final answer. So thank you for following along, and have a great day.